Welcome. Today we want to take a look at how we can use recursion to explore the concepts of Sierpinski's triangle, as well as how we can see actually what's going on with that. So I wanted to actually explore the concept of recursion and use recursion to explore itself as the explanation for that. So I have my public class Sierpinski triangle right here, which is the model package that I'm working with to explore this concept. And we've got a couple static methods in here that we can use to actually describe the Sierpinski's triangle, about the logical calculation of value of how many triangles are created at each depth of recursion, as well as the actual explanation about it using recursion itself. So the first one we have is our public static int Sierpinski, taking an int parameter named depth. If my depth is 0, return 1. Otherwise, return 3 times the Sierpinski of depth minus 1. And again, we can see that when we're using Eclipse, we have that lovely italicized white color right here for my color scheme. But by being italicized, we can see that it's a static call, so I can identify explicitly it as a static method call. And remember, when you're using static methods, you can only call other static methods. Because I'm using recursion, everything I need to know is stored as a parameter inside it, as well as the implicit structure of the stack that we have behind the scenes to actually operate that information. And so I don't have to have any other state information. That's the reason why I'm using a static method to demonstrate this option. Then we have our public static string describe Sierpinski, takes an int depth as well. And so again, it has the same structure. If depth is equal to 0, then I return base call and then the Sierpinski of that depth. So I go up and I call that other static method, so I can grab the calculated value of that. Otherwise, it returns string Sierpinski is a recursive call of Sierpinski at depth inside parentheses using string concatenation, and then plus the Sierpinski of the depth of that current value, and then \n. That's going to allow us to build the actual demonstration of the stack of calls that go alongside with this. I return that Sierpinski value, that string, as well as the described Sierpinski of the depth minus 1 because it's a recursive method. So again, I have to recursively call that information and bring it back. So let's go ahead and take a look at see how we can actually see that operate in action with this inside my demo code. So here we have our Sierpinski triangle demo. So we can see we have our basic triangle right here. We have a couple buttons we can use to go over along with this. And so if I add some triangles to this, I'm going to add a triangle to this. I have a recursive call of Sierpinski 1 to 3, my base call of 1. Increase that again. I have the 9, then 3, then 1. And we can see that the stack itself is building the calls on side here. And I'm using that already existing recursive call to demonstrate that information so I can show what's happening with this. I keep increasing the calls right here. You can see the stack itself is building with that, and I can actually see the result of the stack calls, how it's grabbing that information and bringing that information back here so I can actually see what's happening in the stack, so I can see how the calls themselves happen and they build themselves on top of that. If I cut down the triangles right here, the appropriate reduction of stack is built right there. I get to the base case. If I try and supply less triangles, I can't go any deeper because I'm already at the base case. I can't go further than that. Now, if I get this triangle going up a bit more, I can also see how great this grows right here. I'm right here at a depth of 8. I have 6,561 triangles that are created because of this. And you can see there's lots of tiny triangles right here, so I can actually increase my scale to take a look at this. And I can scroll down here, and you can see that same pattern is recursively built with this, kind of like a fractal. So we can actually have that information, so we can actually demonstrate this really well. One of the things that we can see within the Sierpinski triangle recursive information, we can see that depth of call by looking at the triangles inside here. So I have 1, 2, 3, 4. And so I have 4 triangles going from corner to the edge, and that's that Sierpinski triangle, so I can actually see that depth, and so I can see where I'm at with that, and that works for any of the vertices to edge connections on that, so I can see exactly how many triangles I have for that. And less triangles, I have 3 right here, so 1, 2, 3, and that's where that level of depth, you can see how that happens right there. So a nice little thing we can see within the Sierpinski triangle. So again, we're using the information to make that calculated with there by drawing the Sierpinski's triangle, calculating the number of triangles to draw, and go over that. And I hope this is a great review of how you can use recursion to describe a concept, and how we can use actual recursion to explain recursion itself with some text on that to go along with the actual method call that we're working with it. I hope this is helpful for you. Cheers and see you next time. Have a great day. Bye-bye.